you to. I did try to encourage students to change your exam time, but it's okay. So a few people decided to take it today, which is certainly their prerogative. All right, doing one more thing here. I'm going to do a local recording as well. Always, every time I don't do that, I have a problem with the server and it does not record. Okay, let's see. Record. All right. Okay, now I'm doing a local recording as well. And you should see a blue screen there for just a moment till I bring up a browser window. There you go. All right, I did some work over the weekend, and I want to encourage you, if ever you're not able to get access to resources, let me know. Now, most of you are probably remote, so I think that's probably why I didn't hear from you, but I did note, for example, that there were some issues with my topics list. These links at the top were dead for some reason. They were pulling up an error 408. And the reason is something has changed. I'm actually running these presentations on the old classic Prezi platform, and as they moved to the new version, the links in the old ones became inaccessible for some reason. I'm not sure why. So for a number of these, you were getting the error 408. So if you get that error, this is an online course, so if you are not able to get access to resources, you cannot learn the material. So please bring it to my attention in those intervals when you cannot get access to resources. All right, so let's see. Yeah, there's my exam review. I have 2 of them up. Okay, that's good. All right, there's our topics list. Okay, so I'll check these off. So business process characteristics. Business process characteristics are nothing more than arrangements of work, how work is arranged in an organization. It's a series of steps and activities that someone goes through, or you could have an entire business process embedded in a software. As a matter of fact, when you buy whether you implement payroll software or whether it's accounting software, whether it's enterprise resource planning software, that software often has hundreds, if not thousands, of processes, and of course they're information-based processes that are embedded in that software. The characteristics, so be able to describe processes, the characteristics associated with processes. There are internal, there are customer-facing external processes as well as internal business-facing processes. You have processes that are cross-functional. When I say cross-functional, it means that the process is an integrated set of activities that oftentimes actually is embedded in software. For example, a sales order. When you buy something, the sales order has implications for accounting, who needs to, once the sale is made, then we have to verify the credit standing of the customer, and We might do that in an automated fashion using software validating the credit rating of that. Validating, for example, whether there's a credit available on whatever account they're using, or they're using the credit report. And then it has implications for manufacturing or operations, because they have to plan to, one is either maybe perhaps manufacture that product or prepare that product for shipping. If our business model is something like a distributor. And then finally, it has implications for logistics. These are primary activity processes in organizations. It has implications for logistics because you're going to be shipping the product. Business process improvement. I would familiarize myself. This comes out of Business Plugin 2, by the way, so I'm getting a little ahead of myself, but process improvement, of course, is, there are different ways, there are two primary ways they discuss in Plugin 2 about process change. One is process improvement. And here you have the continuous improvement model where, on an ongoing basis, successful firms continue to update the documentation of their processes. By modeling these processes and documenting them, they maintain an understanding of how they work, where technology is being applied, what their performance levels are. And then, so they have those established measures. They measure performance. And then as performance perhaps lags their competition, or technology continues to evolve, and they identify where, maybe we can use some technology in this particular aspect of this process to improve efficiency or increase information gathering to better inform decisions within the process or within the business. They can implement those kinds of improvements. So know what business process improvement is, be able to define it. You saw the key steps. Documentation. What are the metrics? Measure, and then make improvements, and then you got a feedback loop, and then you're going to measure again. And what once was your benchmark number, if your modification to the process is successful, then that number is going to go up. If we implement a new payroll system, which embeds a lot of automation for various steps in the process in it, and we go from 1,000 payroll checks an hour to 1,500 payroll checks an hour, then obviously we've improved. Harrington's process focus rules, and you can take those straight from the slide. It's really about process. James Harrington's a process improvement guru, and these are some good rules. I've seen various versions of these, but really it's about improving the process. That is the arrangement of work, the activities, rather than, the employees being the issue. You don't want to focus on employees. It doesn't mean that you don't have employee issues sometimes. Certainly you do, but invariably it's really about arranging, that work, and also augmenting or enhancing those processes, giving people technology, if it's appropriate, if it will help if it will help them do their job more efficiently, more effectively. It's really about accuracy, speed, efficiency, effectiveness, etc. You measure the process, key element. You can always change any process. It doesn't always make sense to change processes. If the benefits of using technology to augment a process do not outweigh the costs, then it doesn't make sense to do it. But you can always improve a process. Again, whether or not it makes sense to do it, that's another thing. You should remove barriers to improve, and such barriers can be cultural. Barriers can be lack of capital. In some cases, obviously, that's kind of challenging. Could be an infrastructure issue where you've got an antiquated infrastructure, and therefore we would like to implement this radio frequency ID inventory tracking system. However, we're going to need to upgrade our Wi-Fi network before we do so. You can always develop people. You want to develop people, give them tools that they need, give them, again, helping people do their jobs more efficiently, effectively. Training is part of development. It's really about everybody working together to accomplish whatever the goal of a particular process is. If you have errors, what resulted in the error? Sometimes the error may be the result of something simple, data entry. In some cases, though, the error might be the result of a process. It might be because for example, we may be asking people to do routine things like adding up numbers, when you could embed that algorithm for that calculation in software, and instead of asking that person to do that 500 times a day, which if they are doing that 500 times a day, I can assure you that there will be errors. So that error, you could say, well, it's that individual's problem, but no, it's not really, because calculation is something software does very, very well. So why are we automating that? Why don't we have that embedded in a decision model or a system? Well, the goal is to reduce variation. We want a very consistent process, and we want change to be consumer driven. Okay, so check. So I think we've kind of covered, we probably wore process down a little bit. That's Harrington's rules, pretty good. Process reengineering represents dramatic change in processes. So process reengineering is just improvement on a more elevated scale. So when you're looking at, and if you look at the steps in reengineering, it's really about, defining the scope of some initiative, and clearly when we're talking about reengineering, we're talking about a radical transformation of those activities in a process or a set of processes. And we need to define the scope, and the reason we define the scope is because reengineering initiatives can kind of quickly get away from you in terms of encompassing different aspects of the business. So you need to define the scope to, say, a particular area or set of processes in the business. From an analysis, how are we going to simplify, streamline, or eliminate low-value processes, and then transform the targeted ones? You're going to have different ideas, different solutions. Some of them may be commercial off-the-shelf software, for example. Some of them may be custom software initiatives. Evaluate the alternatives, and then once you make a decision, devise a plan for implementation. And once you have the plan, you got to get the plan approved by senior management. Then you execute it. And whether you're building a building or implementing a software-driven solution, this process is pretty much the same from a high-level view. But again, radical transformation. Whereas improvement, you're looking at 10 to 30% improvement in terms of the metrics associated with processes. When you're looking at engineering initiatives, process re-engineering initiatives, you're really talking about radical transformations. Some of the business models we've talked about really were re-engineering initiatives. Sometimes re-engineering can actually be more simple. So in the case of, this is a well-known case where Ford Motor Company was, in the early 90s, looking at re-engineering their accounts payable department. They had about 500 people working. They had inefficiencies throughout the system. The biggest problems they had was they had, when they had a situation where they had a purchase order that had been issued, and then you got an invoice from a vendor for goods delivered. The PO did not match the bill of lading of the shipment. Bill of lading is a document that indicates what's on a shipment. You had 500 boxes of this, 200 boxes of this, 2 pallets of this product, etc. And then you get an invoice that matches the bill of lading, but the bill of lading does not match the purchase order. In some cases, all 3 documents wouldn't match each other. So reconciling these kinds of things is very arduous. It also creates problems or relationship issues with vendors. And then somebody went and visited Mazda, and Mazda was not nearly as large a company as Ford, but they only had 5 people doing accounts payable. And they started investigating why, and what they found out was really quite simple. Mazda had a database that they made available to shipping clerks, or actually it was receiving clerks, and the clerk could check the PO to see if the PO that corresponded with a shipment, was it the same? In other words, did the bill of lading on the shipment that was, if it's a truck backed into the dock or a rail car on the side rail, did the shipment match the PO? If it did, they accepted the order and entered it into the computer system. If the shipment did not match the PO, then they simply sent it out. They didn't receive it. They sent it away. And so it was part policy driven, part technology driven, because it, basically it used a database to make available all the purchase orders that were issued by the procurement department, and then they were able to reduce accounts payable workforce by about 75%. They did digitize the procurement accounting process, and then ultimately, oddly enough, this ended up, one would think that rejecting these loads would not improve vendor relationship, but actually it did, because it created it created a very consistent shipping environment, shipping and receiving environment for Ford. So that's an example of, in this case, it was quite a different re-engineering policy process. So it was really radical transformation of their policy, not so much their systems. It was just the rules about how the process actually worked were dramatically altered. Taco Bell, another re-engineering initiative. Early 90s, they moved their food preparation, where they had been preparing food in the restaurants, they moved to centralized commissaries. And it helped them achieve greater quality control, lessen employee injuries, and encouraged customers to better delivery. So, different, again, when you think of re-engineering, really radical alteration of the process. Again, if you look at the online retailing models now versus traditional retailing models, really radical transformation of a lot of processes associated with the consumer retail experience. There are some criteria for process reengineering. The only thing I would say about reengineering, there's more risk in reengineering because reengineering initiatives represent a fairly radical transformation of a significant part of a process, or perhaps all of a process. There's more risk. Because you have more risk, those reengineering initiatives, you need to have very good reasons for pursuing them. Doesn't mean that you don't do it, but there need to be compelling reasons, and those reasons are, I think I have these here, I believe. Here we go. Do you have a broken process? Will it succeed? Does it impact strategy or strategic direction? Does it impact customer satisfaction? Do you have an antiquated process or below best in class? In other words, you've got competitors who are doing much better than you are at whatever the process is, whether it's procurement, logistics, inventory management, marketing, etc. Is it crucial to improve production? So do you have other, do you have other processes that are dependent on it? So it's a bottleneck. Will savings from automation be very clear and visible? Will we, and of course the big one is, will we make money? Will return on investment be high? And hopefully and preferably immediate. Okay, let's see. Hardware components, I'm not going to go into detail about those. You can review that. That is Business Plug-in 3. Various categories of input and output devices, storage devices, hard drives, solid state drives, monitor considerations, know what resolution is. It's the number of pixels across and down the screen. That matters. What matters also is the dot pitch, which is the distance between the two pixels that are the same color. So the distance from the center of those. The closer those are, the better resolution of the monitor itself. So the number of pixels, the dot pitch are kind of critical issues as it relates to monitors. You have storage mechanisms, and again, we talked about different storage media. You should be able to generally describe those, kind of how they work. There's magnetic storage, which is, you've got hard drives, you still have tape. It's magnetic oxide. It uses an electron microscope for storing data, changing the polarity of positions on the screen. You get a lot more storage space from magnetic technology than you do from electronic technology. Primarily, it's a cost issue there. Solid state drives are more expensive, but they have a number of benefits. They're faster, so they have a more rapid seat time, and write time. In addition to that, solid state drives don't get fragmented. The data doesn't get fragmented, so you've got some geometric issues with magnetic drives where over time your data kind of gets in different blocks or segments on the disk, and it's like a library getting where if you had a library and you didn't have fiction here and you didn't have history over here, you just put the books in empty spaces, and we call that dynamic inventory. You put the books in empty spaces, and you had a card catalog, and it means that every time you wanted to find something, you had to go to the card catalog and pull it. You couldn't necessarily just follow some numbers where, you had a common type of book. You had all the fiction here, and I've got a list of numbers, and I can find what I'm looking for. Wouldn't be that way. You'd have to go back to the card catalog all the time. Disk storage is kind of like that. Storage capacities, we talked about the storage, the encoding storage. Remember the byte, which is a byte is 8 bits. Okay, and then that we have a number of encoding standards. That the Unicode standard is the new one, and it's a 16-bit storage standard. But the one that you have to do the binary math in is going to be the byte. It's the American Standard Code for Information Interchange. You need to be able to convert binary to digital and digital back to binary. Just so you understand that, we take these ones and zeros and we arrange them in groups so that they can then represent the higher level elements that we need as humans in order to interpret that information or to write code. And that is, the alphabets, the ones, the numbers, the characters. Okay. Also, there are a few questions on the CPU, the processor cycle or the CPU cycle. So you should know that. You should also know the different components, the control unit, the arithmetic logic unit. There's a clock. Know what the clock, and by the way, know what clock speeds modern CPUs are capable of today. Recall that today's modern CPUs are comprised of multiple cores. So we have multi-core CPUs. So if you're sitting there calculating, how many bits that a modern CPU will process with each cycle, for example, if it's a 64-bit CPU, and it's got 4 cores, then that's 4 times 64 bits that it will process each cycle. Okay, not second, but cycle. Each cycle, remember, modern CPUs run at, 3.5, 4.6 billion cycles per second. So they're amazingly fast. The word length matters. How long is the word? 64 versus 32, 64 versus 128. Some gaming CPUs now process 256 bits per second. So they're really, really fast, designed for specific activities like gaming. So you should know the steps in the processor cycle and be able to describe them. Not be able to just tell me what they are, but describe what's going on. If you look at plug-in 3, there's some excellent diagrams for the processor cycle. If I can find them. Ah, there we go. And there it is. There's the processor cycle. Fetch, decode the instruction that was fetched from memory, then you're going to execute it, then you're going to write it back. And you should know that operating systems are word length specific. In other words, if you're going to install a particular version of a Windows operating system, it's certainly going to be a 64-bit operating system. It's going to be specific to that word length. An older version of Windows Might be a 32. Windows 7, for example, had a 32-bit version, and then later on they evolved it to a 64-bit version. ASCII encoding standard, be able to convert binary to digital. So we have a binary number 10111011, and convert that to digital for me. Somebody tell me the number. Now, do not use a calculator because you will not be permitted to use one when you're taking the exam. So convert that. I'll give you just a minute. Somebody tell me what the answer is. And when you finish, just type it in the Q&A area. Okay, I'm getting a little discouraged. I'm not seeing anyone post anything yet. Does anyone have any questions on how to do it? All right. Well, this is base 2. Each position represents a factor of 2. So 2 to the 0 is first position, 2 to the 1, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, and finally 2 to the seventh. So you're simply going to add these up. So if you have a 1, then that means that the bit is set. If you don't have a 1, then the bit is not set. Okay, so if the bit is set, it's going to be, for converting it to decimal, it's going to be whatever that power of 2 actually is for that particular position in the binary digits. So 2 to the 7th is 128. So that is a set bit. So 128. Now the 2 to the 6th position we did not set. So that's 64. So we're going to zero that out. But then we set the 2 to the 5th for 32. We set 2 to the 4th for 16. We set 2 to the 3rd for 8. 2 to the 4th was not set, so that's 0. 2 to the 1st is equal to 2. 2 to the 0 is equal to 1. Anytime you have that, you know you're going to have an odd number when you set that final bit. So you simply add these numbers up, and you've got 160, 176, plus 10 is 186. I believe it's 187 is what we're looking at here. So this is equal to 187 decimal. Okay? So do another one. Again, 0, 1, 1, 1, 0, 0, 1, 1. Okay? So again, 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th, and 2 to the 7th. We did not set the leftmost bit, but we did set the 64. So we would have 0 plus 64 plus 32 plus 16. We did not set the 8-bit, or 2 to the 3rd. We did not set 2 to the 2nd. We did set 2 to the 1st. 2, and 1. Add these numbers up and you get 96 and 16 is 112. I believe this is number 115. Okay. Now you might be asked to do a number that contains more than 8 binary digits. And it's simply a continuation of the same model. So, for example, if I had now this has got 9 ones and zeros. So there are 9 there. So extending the model, now you have 2 to the 0 power, 2 to the first, 2 to the second, 2 to the third, fourth, 2 to the fifth, 2 to the sixth, and 2 to the eighth. Okay? So we have 2 to the eighth. So that means that, and that bit is set, so this is 256. Plus 128. Because we did set the 128 bit. We did not set the 64, but we did set the 32. We set the 16. And we set the 4. And if you add these numbers up, 14, 2, 6, 16, and 6 is 22, 26. We're going to carry the 2, that's 7, 9, 12, 13. And then we're going to bring this over, and that's 436. This is equal to decimal 436. Okay? So again, you might get a question that extends that out. Let's say you're given a decimal number and you need to convert it. So 211. And what is that equal to in binary? Well, the way to work these is, first of all, we're going to be dealing with, I'm going to give you a number where you will only need 8 bits. So you know that the highest number that you're working with is 128. So will 128 divide into 211 with any remainder? And the answer is yes. So we're going to set that first bit. And we're going to subtract. So that's 72 plus 11. 11 minus 8 is 3, and 10 minus 2 is 8. So that gives us a remainder of 83. Okay? Now, the next bit is 64, and 64 will go into 83 with some remainder. And that gives us 19. Okay. The next bit is 32, 2 to the 5th power. This is 2 to the 7th, 2 to the 6th. And you do start from the left. 2 to the 5th is 32. It will not factor in, so we're not going to set that bit. 2 to the 4th will be set because that is 16, and that gives us a remainder of 3. 2 to the 3rd is 8. We will not set that because it will not factor in with some remainder. 2 to the 2nd is 4, and that will not be set because it will not factor in with some remainder. 2 to the 1st is 2, and that will be set. I'm going to raise this up, giving us a remainder of 1, and we will also set the last bit, 2 to the 0, because it's an odd number. And that gives us 1, and we zero our number out. Okay, so this is equal to the number, decimal number, 211. Okay? Okay, any other questions about binary to digital conversion, digital to binary conversion? Very good. All right, so here we are. We're on different software categories. Well, basically, there's operating system, there's utilities. On a Windows machine, it's the Windows operating system. Mac, it's the Mac OS. What's the latest version now? I can't remember the name of the latest version anyway, but it's the Mac OS. You've got Linux. Linux is a Unix-like operating system that runs on microprocessor CPUs, like the Windows Intel CTU, the Intel central processing units. Application software is what you do your work with. It runs in the operating system environment. Utility software is kind of an extension of the operating system environment. Like the control panel in Windows is an extension of the operating system. So be able to differentiate between those kinds of software. Now we're getting into networks. You should know what bandwidth is. Bandwidth, of course, is the amount of data that a network can actually transmit at any time interval. We do measure data network transmission speed by bits. You should know that. Typical network speeds today, the network in this building is like a 10 gigabit. Big G, little b. If it was a big B, it would be bytes, but instead it's bits. So that's 10 billion bits per second. You should know how about bandwidth. There's a slide in plug-in B5 that discusses broadband. And of course, broadband is a technique where you divide up your media, whether it's air, whether it's wire, whether it's fiber, you divide it up into multiple channels and you transmit or broadcast data across all of those channels simultaneously. So you might have more than one channel, and that's called frequency multiplexing. So be able to describe what broadband actually is. All networks use broadband technology. All of them do. So be able to describe those. Network interface cards, that's the interface, whether you got a smartphone, whether you have, whether it's a PC, your network interface card needs to match your network type. If your device is on a Wi-Fi network, you got to have a Wi-Fi network interface. If you're using Bluetooth to interface with your peripherals, then you need a Bluetooth interface. If you're plugged into an Ethernet network, you've got to have an Ethernet network interface. It's got to match. The network interface card is bound to the operating system functionality with a driver, and you have to install and configure that driver. You should know what switches and routers are. They're two different devices. They serve different functions on a network. Switches are the LAN device. They're associated with star networks, for example. Routers, on the other hand, interconnect networks. Different network topographies, or different network types. You should know what a LAN is, what a WAN is, what a MAN is. If I give you a description, you should be able to select, pick which one, or select the true-false question, for example, which one I'm talking about. Same thing with peer-to-peer versus client-server models. Those are the two predominant network types that we talked about. Peer-to-peer, of course, is where, again, it's what it sounds like. Each host is a peer. Each peer has the same rights as far as resources. Security, they can share resources, whether it's a peripheral device like a printer or whether it's a file, and they set the policy at the local level. Client server, on the other end, you have a client that you authenticate to. That client is what's called a distributed computing model. And I'll find that little diagram. And basically, it means that usually a client server, it basically is a distributed computing model where some of the storage and processing is managed by a client, and then some of it is managed and processed by a server or servers. Typically, most client server models have multi-tiered type computing models where the logic might be managed by server 1, and then the data might be managed by server number 2. And maybe server 1 is also managing some of the presentation, and client 1 is managing a large part of the presentation that the end user is using. Okay, let's see. All right, so that's client server versus peer-to-peer. Peer-to-peer, again, there's no distributed processing, sharing of resources. There's no coordination of processing and data storage between client and server and peer-to-peer. Peer-to-peer, you can share resources, but unless you got some kind of specialized software, you're not coordinating processing activities. You should know about network topologies. There was the bus network, there was the star network, there's hybrid networks, and you've got some diagrams associated with those in Plug-in 5. I talked about the Ethernet protocol, which is the protocol that is premised on the bus network. The bus network being, I could draw that, or I could probably pull it up really quickly. Yeah, here we go. So here's the bus network. Everybody's connected to a cable. There are terminators on both ends, and all the electricity and everything comes off the network interfaces from the devices. The software has built into it the protocol for communicating over such a structure, and this is the Ethernet protocol. And the way it works is each one of the device listens to the line. Is there any conversation? No. Then I'm going to transmit. And if I happen to transmit at the same time, if device number 1 happens to transmit at the same time as device number 2, and there's a collision where the data is destroyed, and if the collision is detected, then a retransmission occurs. Of course, all of this is happening at the speed of light, so it's very, very fast. Let's see. TCP/IP protocol, know what it is. Be familiar with its layers. You don't have to really, I'm not going to ask you to describe what its layers do. But, its general architecture, there's a couple of diagrams on TCP/IP. It, of course, is the protocol of the Internet. You should certainly know that. The Open Systems Interconnect model developed by the International Standards Organization. The TCP/IP is modeled after that. You should know what the OSI model is. It's kind of a set of rules for devising protocols. The different network addresses, you've got the TCP IP address or IP address, which is it's not a physical address that's actually coded onto the interface. It's an assigned address that is assigned through usually some sort of administrative apparatus. When you log on from your home network or when you log on the network here at USC Upstate, you are assigned an IP address. One of the services that is used to assign it is called DHCP, Dynamic Host Control Protocol. It allocates an address to you. You have that address for the duration of your connection, and once you drop, that address goes back to the server. There's some discussion over the different kinds of media. You should be able to recognize them and select which is appropriate. You've got wired media, you got twisted pair cable, you got coaxial cable, you've got wireless, so airways, you've got fiber optic. And again, I talked about broadband. You need to be able to describe what broadband is. Know what last mile technologies are. Last mile technologies are technologies that run on those wires that come into the business or the home from the central office. And we call it's a twisted pair wire, an RJ11 standard. And it's a limitation, really, to this country's infrastructure because those wires are really not that robust. If we had fiber optic running into everyone's home, everyone would have unlimited bandwidth. But instead, many places in America still, the main connection for an internet service provider, the main media, is that copper wire that's been pretty much the same for the last 70 years or so, or longer. So know what the last mile is. The last mile has significance in terms of who and how many people have broadband access versus, less than adequate access. And even if they have broadband, if they're using that last mile, there's only a finite amount of data you can get over that wire, given its limitations in terms of its size and voltage. There are different kinds of business networks I discover that I talk about, and these are things you would, if you had a business and you needed to connect your main office with your warehouse. Depending on what your bandwidth needs were, you would use one of these. You have like a T1 line, which is a 1.54 megabits per second. A DS3, which I think is 45, and then an OC3, which is like 155 megabits per second. All of those are circuits. When you lease them from the telecommunications carrier, you own them for the duration. You don't own them, but they are yours. No one else is transmitting on them at that time. Now, another option is to buy network services, which are like frame relay and asynchronous transfer mode, or ATM. And there are some schematics or some imagery, I believe, that I have related to such services. Yeah, here we go. Kind of illustrates. And it basically, you buy network connectivity locally. So if you want to connect, this is the main office, MO. And you want to connect all of these locations to the main office. With frame relay or ATM, what you do is you go to a company like Level 3 Communications or AT&T or Verizon or whoever, and they will sell you a business service solution where you connect to their system locally. So if this is New York, you're going to connect in New York. If this is Atlanta, you'll connect in Atlanta to their cloud, and then they will move your traffic in a secure fashion through their cloud to its ultimate destination, which is here. And you can interconnect. Also, when all these locations that are interconnected to this cloud, it's you can think of the cloud as it's routing traffic from whatever location to whatever location the transmission is destined for. Okay, know what a VPN, virtual private network. That's basically an encrypted tunnel through some sort of network, public, private. We use VPNs. The infrastructure folks on this campus use VPNs to secure certain types of transmission on their networks here on campus. So it's not really, it's a security mechanism. It's not exclusive to something like over the internet. But certainly if you're connecting, if you go to work for, let's say, a bank or a company that you access their web portal from remote, you're in a coffee shop, you're over in Paris, you're drinking coffee, enjoying the atmosphere, and you've got wireless access there, which is a public network. You've got your laptop, and before you connect to the portal, they probably require you to connect using a VPN gateway, and it just tunnels through the internet, and it's a secure connection for you from that location to your corporate headquarters, and then you can pull up whatever privy information that you need to. Voice over IP is basically, it's about transmitting voice within the organization over the same data network that we transmit, that our information systems use. Bluetooth technology is, again, another wireless, so you should know what Bluetooth is. You should know what Wi-Fi is. I think we discuss actually, we don't discuss WiMAX, but Bluetooth certainly is something that we discussed. So what's the role of information? Now we're getting out of networking. What's the role of IT in business? The role of IT in business is to augment or enhance, automate the information aspect of processes within the business. So, information systems combine people, they combine information, they combine systems and software in order to accomplish information-based work and to streamline information processes throughout the organization. Know what the definition of MIS is. There in Chapter 1, they discussed the data hierarchy, data, then you have data that's been processed in some way, and it's converted into information that is not represented simply by the data element itself, but now we instead of a sales, instead of just two of these devices, now we multiply those devices times the price and we get a total for that. That's information. If we have sales numbers, we add those sales numbers up, and then we have a total sales. And if we then organize those sales by product or by region, now we've got additional information. Knowledge, of course, is specific to the individual, what the individual brings to the table. Along with information, they bring knowledge, they bring understanding, they bring a certain type of, whatever their particular skills are that they bring an understanding. Perhaps they've got a lot of experience, so that's knowledge. Business intelligence is contextual application of, it's really about context. It's like anything, intelligence. What is intelligence? It's It's gathering information, analyzing in new and unique ways, statistical analysis, data mining techniques, and being able to garner more and more and more attributes that are relevant or germane to the particular problem we're working on. And that's business intelligence. The more you know, the better informed you are in terms of, your decision process, and typically that's going to result in better outcomes. So if, you're able to consider 30 variables that might have an impact on your decision outcome versus someone else who has access to only 10, then you're probably going to have better outcomes. Information characteristics. I think this is related to, this is chapter 1. You know what? I think that's chapter 6. So, yeah, basically it's just, that's actually another chapter. Don't worry about that one. I'll remove that. Information characteristics, I believe that's relevant to chapter 6. You should be able to do a SWOT analysis, understand what that is. There's a very nice video in chapter 2, SWOT analysis, the 5 forces model, the value chain model, all of those. You should review those, understand them. You also should know the 3 generic strategies for competing. Compete based on cost, compete based on focus, and compete based on, focus and specialization. And finally, differentiation. Yeah, I'm sitting there going, okay, specialization, differentiation. Specialization and differentiation are 2 different things. Specialization is focus. Differentiation is, setting yourself apart from a marketing perspective, from an operational perspective, from a, a customer service perspective, are all 3 mentioned. Okay, so any questions? I think that's pretty much everything. Also, the exam, you'll find some questions in the exam that are derived from the book. So I do expect you to do the Smart Book lessons, and I do expect you to read the text. Part of learning is being able to read and absorb information from texts, and then being able to assimilate and apply that information in the appropriate context in a question. So you will, on occasion, see in the exam there are questions that are derived from the text. Usually they've probably been at least mentioned in class. Also, if I've asked you to read articles, it's not unusual for me to put a kind of a broad question in there, and it really is just an inquiry as to whether or not you actually read the article. I'm not going to ask you very specific details from that article, but, I might just put a broad question out there that inquires as to whether or not you were keeping up and you actually read the article. Okay, let's see. Let's take the roll. The one you couldn't read, don't worry about that one. That was the Wall Street Journal one. The one that was about Amazon changing their algorithm and using profit as one of their major, if you believe the insiders, they said Amazon was using profit as one of their major attributes for determining search results. So profitability for Amazon was determining that. And you can say, well, why is that a big deal? Well, because Amazon really is a marketplace. They're so large that they're a marketplace, and there are a lot of third-party sellers that sell through Amazon. So, they're almost like their entire they're their own virtual space. So that becomes an issue. Now, it might not be an issue in the United States so much as it is an issue in, say, Europe. Europe recently frowned Google. They fined Google about $2.5 billion, mainly for what essentially was the European regulators viewed it as kind of rigging their search model. I have a question in the Q&A. Will there be Excel questions? No. There are no Excel questions on the exams. Your Excel questions are, mainly Excel projects are, work-related. They're work-oriented projects. And for you to do the projects and learn the functionality of Excel using hands-on, applications. So there will not be any Excel questions on the examination. Okay, let's take the roll. Call it a day. I'm going to stop my recording now.